Alright, we're going to start this mini video workshop with this equation. We know hydrogen reacts with oxygen to produce water. Hydrogen and oxygen are both diatomic molecules, which is why it's H2 and O2 reacting with each other to produce water. If we take a picture or use the molecule pictures, we have one molecule of hydrogen reacting with one molecule of oxygen, producing one molecule of water. But if you remember from the law of conservation of mass, the mass of the reactants and the mass of the products must be equal. Matter cannot be created nor destroyed, which means something has to happen with this oxygen atom. It doesn't just disappear. So hopefully by now you remember how to balance equations. And if we put a 2 in front of H2O, that indicates we're going to have 2 water molecules. So then we would have an even number of oxygen atoms. However, this also changes our hydrogens. Now I have 4 hydrogens on the product side and only 2 on the reactant side. So if we put a 2 as a coefficient here, we'll get another hydrogen diatomic molecule. And so now we have a balanced chemical equation. So I kept saying molecules and atoms and things, but I hope you recognize that molecules and atoms and formula units, these things are so small that I'm not just going to have 2 little hydrogen molecules reacting with 1 little oxygen molecule to produce 2 little water molecules. Okay? What we're actually going to have are moles of hydrogen reacting with moles of oxygen, producing moles of water. So these coefficients actually represent the number of moles of a substance. And remember, a mole is equal to 6.02 times 10 to the 23rd molecules or atoms or formula units, which means we're going to have a lot of these. Obviously, I can't draw them all or make them all appear, but you get the picture. So if we continue with this reaction, with this equation, we're going to talk about what are called mole ratios. And remember, a ratio is just the quantitative comparison between two different things, so looking at the amounts of two different things. Well, a mole ratio is going to be a ratio of the moles of one substance compared to the moles of another substance in a balanced chemical equation. So if we're looking at this, here I'd have 2 moles of hydrogen. And if I want to know what's the ratio between hydrogen and oxygen in this equation, I have 2 moles of hydrogen reacting with, there's no number here. So I hope you remember that if there's no coefficient, that indicates there is 1. So if I have 2 moles of hydrogen, the mole ratio is going to be 2 moles of hydrogen to 1 mole of oxygen. But this isn't the only ratio in this equation since there's multiple substances. I can also say, well, 2 moles of hydrogen to 2 moles of water. Yes, it can be simplified to 1 and 1, but for what we're going to be doing in the future, I'm just going to leave it at 2 and 2. And again, this is not the only 2 ratios. We also have oxygen to water. So there's 1 mole of oxygen to 2 moles of water. For this next example, I'd like you to pause the video and see if you can figure out what all of the mole ratios are in this equation. So please pause now. Now looking at this, we have 2 moles of magnesium, no number here, so 1 mole of oxygen, 2 moles of magnesium, 2 moles of magnesium oxide. Again, I'm not going to simplify it for future purposes. And then 1 mole of oxygen to 2 moles of magnesium oxide. The next reaction is going to be a little bit trickier, so again, I want you to try it on your own. Pause the video now, see if you can get all the reactions, or excuse me, all the ratios, and then check your answers. Did you remember to balance the chemical equation? Because right now it is not balanced. And if you did not balance it, you're not going to have the correct ratios. So with a balanced chemical equation, 1 mole of nitrogen to 3 moles of hydrogen. 1 mole of nitrogen, 2 moles of nitrogen trioxide, also known as ammonia. And then 3 moles of hydrogen to 2 moles of ammonia.